In this video, we're going to continue to look at the electron transport chain, and we're going to start with complex 2, also known as succinate coenzyme Q oxido reductase. And this is actually from the citric acid cycle. It contains succinate dehydrogenase. And what this complex does is it takes electrons from succinate and gives them to coenzyme Q. Here we have some more iron sulfur chains again. This is how we are transferring electrons from our succinate. We have a cytochrome B560 in there as well to help to transfer electrons. However, this complex does not create enough energy to drive ATP synthesis like we saw in our last complex, complex 1. Now, the substrate for succinate and the ubiquinone binding site is separated by 40 angstroms. So again, we have this long chain where we give electrons to FAD. FAD gives electrons to these iron sulfur complexes, which eventually will give electrons to coenzyme Q. Now, that cytochrome we talked about, cytochrome B560, it has a heme group with it, and this is how to help catch any stray electrons to stop any side reactions. So in case something escapes during this chain, heme B is kind of like a net to help catch it before it can leave and ruin anything inside the mitochondria. And complex 2 is allowing these high potential electrons from succinate to directly enter the electron transport chain by bypassing complex 1. This means that complex 1 and 2 don't operate in a series. That is, you don't go to 1 to 2. You either go from 1 to 3, or you start at 2 from succinate, and then you can move on from there. That moves us to complex 3. In complex 3, we take electrons from coenzyme Q and we're giving them to cytochrome C. Here we have different types of cytochromes and more iron sulfur clusters. Hopefully we're aware what these iron sulfur clusters are doing now. This protein is again another massive complex. It's a homodimer, each with 9 subunits in each dimer. It's in the membrane, and you also have a thick portion in the matrix, and you also have a portion in the intermembrane space as well. Now, to give electrons from coenzyme Q to our cytochrome is actually a very involved process, because coenzyme Q will deliver 2 electrons. Cytochrome can only carry 1 electron. So to give both electrons away, we have something that's called the Q cycle. So each coenzyme Q undergoes a 2-cycle reoxidation reaction in which our semiquinone, that is our 1 electron version, is a stable intermediate. And here, complex 3, we actually have 2 different sites in which we can bind coenzyme Q. The Q0 or QO site and the QI site. Now let's look at this cycle, and we're going to start by looking at the top picture here. So the first thing that happens is that coenzyme Q with 2 hydrogens coming from complex 1 will bind our QO site right here. There we transfer 1 electron to an iron sulfur protein unit. This electron can then go to cytochrome C. Cytochrome C can go on to complex 4. Now, when we lose this electron, we also will pump out 2 hydrogens into the intermembrane space. And we're left with our coenzyme Q that has an extra electron, our radical. Now, this extra electron will be passed to cytochrome Bl, and then that electron will be passed to cytochrome Bh. And this coenzyme Q, having lost its electron, will go back to the fully oxidized version of coenzyme Q. And once in its fully oxidized version, it will leave this QO binding site and move over to the QI binding site, where it will be on the end of the cytochrome to regain the electron it just gave away. So it's almost like coenzyme Q is at the top of a stairway, and it will drop an electron down that stairway, run down the stairway, and then recatch the electron to become the negative version. The reason why this is happening is that in this negative version, it probably cannot leave the Q0 site. So it has to give my electron to these other cytochromes as a temporary placeholder. Now I'm not charged. Now I can move through the protein. Now I'm in this QI site, and now I can become charged again. All right, so that's our first cycle with coenzyme Q. Our second cycle is very similar in that we have a separate second molecule of coenzyme Q with 2 hydrogens binding at the QO site. Same thing happens as before. We give 1 electron to our iron sulfur protein unit, which can give an electron to cytochrome C, and we pump 2 electrons out. We have a Q that has 1 electron now. We give it to BL, which will give it to BH. Now, this Q, though, this does not go into the QI site because the QI site's already full. Our QI site has our enzyme Q from cycle 1 with our 1 electron. This Q that we just created in cycle 2, that's free to leave. And now it can go back to complex 1 or complex 2 and gain more electrons. But this coenzyme Q will get a second electron, and then it will pick up 2 hydrogens from the matrix. And then that's free to leave, and it can go through this cycle again to start donating electrons and pumping out the hydrogens it just collected from the matrix into the intermembrane space. So you can see in this Q cycle, it's a clever way that 1 electron is being passed to cytochrome C, and it's also a clever way that we're taking hydrogens from the matrix and we are pumping them into the intermembrane space basically for free, because we're just moving an electron around, or 2 electrons around, to things that want to become more and more reduced, and so we're using that energy to move hydrogens. And those are all the text for the second cycle right there in that slide as well. And so that's it for this video. I will see you in the next video.